Okay, so yeah, let's get started. So thank you everyone for joining this series today. As I mentioned, is the last session of the series, and I know there might be some new members who are joining this series in this joining this session for the first time. So just to give them a quick introduction, who we are MLT Machine Learning Tokyo, and we are an non-profit organization based in Japan. Our main aim is to democratize machine learning. And how do we do this is using the three O's: open science, open education, and open source. So, and we are a big international team of researchers and engineers comprising more than 9,500 members on Meetup. So under MLT, we have the MLT Edge AI Lab, where we try to experiment with different type of open hardware. We try to come up with experiment with some things around Jetson Nano, microcontrollers like Arduino Nano. Then we also previously did some experimentation with FPGA and tried to participate in one of the competitions where we got a third rank in the competition. So basically, our aim in MLT Edge AI Lab is to create an open environment where people can try different things without hesitation and share with the community what kind of projects they are working on. So for a long time, we were a bit like we didn't had much physical sessions due to COVID, but this year we started this series. It was a 5-week series with 4 sessions total, and our main focus was on how to use microcontrollers, how to do edge AI on microcontrollers. And these are the organizations. Naveen, we have Naveen Kumar. He's a senior technical scientist at Regain, and if you see his profile, we have the link here on Hackster. You can see like different kind of edge projects. Like he has been working with microcontrollers, different circuits, I think he also has drone projects, and like you could see how he plays with different microcontrollers and create variables and edge devices quickly. So I think it was like when we discussed with Naveen, we thought like we need such kind of like we need to design some session which will be offline because we cannot do online sessions. So we thought of like having a session where we could demo some applications and show how to deploy an AGI pipeline, and then encourage members to build their own apps by themselves. And then I was also helping Naveen. So for me, just my introduction, I'm Yoovraj, and I also like working with sorry I also sorry yeah, I like food and robotics, and I especially love making robots for kids. And like one of my hobby is like to build a robocar for kids, where we can teach kids how to use simple programs to run a particular car. And yeah, the another one was also like I think a small humanoid robot, where I tried to 3D print a open source robot. So both of us, when we designed this series, our main aim was like within this series, within the 4 sessions, we will show them initially the overview of AGI applications, where we show why AGI is so important in now, especially when we have so much devices around us, how we can leverage this device's power to deploy cool machine learning or AI apps on the device. So we in the first session, I think we just generalized the entire process of AGI. We try to make it fit, try to figure out what are the main building blocks of any kind of applications, starting from data collection on the edge to deployment on the device. So we figured out like there are some edge components, there are some cloud components, or the PC components where you need huge resources like either a huge CPU or GPU resources to train a model. But then again, you have to convert that, quantize that in order to fit the model onto the device, because the device has so many constraints of like resources. So we talked about that in the first session. In the second session, we talked about like I think Naveen demoed us how he built a application using the motion sensor, the IMU unit on this particular microcontroller. We targeted Arduino Nano Arduino Nano 33 BLE Sense board because it already has so much of sensors on the board. So he demoed how he can detect a fan speed based on the vibration generated by the fan. In the third session, we demonstrated an audio-based application where Naveen made a snoring-based app where he already trained a model using the snoring data and then deployed that model on the Arduino Nano and played a sound. So the inference was real time where he played a snoring sound and the model was able to pick up this snoring sound and then do some physical activity like he attach a vibrator to the motor so that when someone snores, it will vibrate. Yeah, and then today is the last session where we will, after this series, we asked members to try to build their product, build their applications based on this examples. And today we will see we have two members from the community where they will showcase their projects which they build during this 4-week series. So apart from that, I think one other summary which we want to look back is during these 4 sessions, during the last 3 sessions, what we did was also brainstorming activity, where after every session we use the whiteboards from using the Mural app, and then try to brainstorm around like what are the different components, and when you consider any kind of application, what kind of blocks you need to take care of while building any application, like the data processing or the mainly data collection, processing and storage, then the cloud component, and then the deployment component. So I think this was great because when I see the whiteboards later on, we see like a lot of different ideas come in. I think I remember when we initially did this session, we had around almost like 10 ideas, 10 or 12 ideas, different ideas in the first session itself. Yeah, and I think this is great to start somewhere, like so that we can do brainstorming with the team and then start building this application. Okay, so with that, let me just hand over now the slides to the project cat activity direction. So I think let me just stop sharing. So Lynn will be introducing his project. I think it's a really good project. So let's see what Lynn has in his project. Lynn,
Okay,
can you please take it over? Yeah.
Okay, thank you, Yoovraj. Okay, I share my screen just a second. Yeah, can you could you see it?
Yeah, we can see your slides.
Okay, yeah, okay, then I will start. Okay, my project is like cat activity detection. So, well, basically, well, I just first introduce myself. And yeah, I am Chen Lin, which I'm right now living in Tokyo and currently working in techno data science. And I'm from Taiwan. And my background is not really about computer science, some stuff. I'm studying chemistry and don't even know code I think I know code for 3 years ago. So yeah, it's quite a challenge to me. Yes. And this time the project's protagonist is this guy. No, this cat, not guy, is Tapio. And he's my cat. And right now he's 2 years old. And this is the picture which taken from before. And this is the situation right now. She got a little fatter when we go on a vacation, and he eat a lot of things, and like some cat chew, you know, in Japanese, a lot of very nutrient stuff. So right now he become very fat. So my thought is that I can make a board to monitor his activity, like whether the cat is exercising or not, or he's just sleeping on the couch for all day. So yeah, this is one of my purpose. And I divide this project into 2 parts. Like, well, basically I'm a little greedy. I using 2 parts of the project, the movement, like using the INU to detect the movement. And the other part is like using the audio section. And in movement section, I want to detect whether the cat is exercising or not, like whether he's moving or he's walking or he's just sleeping there. And the second one is that, well, this is the more advanced target. Right now, I haven't done much trial in this one. Like I want to divide his activity into maybe like a medium movement or easy movement, which I can calculate how much he has exercise. Yeah. And on the sound part, the audio detection part, like I want to detect whether the cat is meowing or he's trying to talking to me. Yeah. And if this work, I want to further classify what his sound is, the meaning of his sounds, because, well, I look at some recently news like the Ig Nobel Prize winner have some paper which she just research on some what's the meaning of cat sounds, like whether he's hungry or he's just trying to say hello to you. So I thought that was cool, and he also had some data. Yeah. So further part is I want to maybe communicate more with my cat. Yeah. And the first part, I will talk about the detection part, detection and movement with acceleration, like using the IMU. Yeah, and after starting this project, immediately I encountered some of the problem, like what to use for powers, because like maybe in Naveen's snore detection, the human will take the chip, or it is not carry on the source of the object, so that maybe not be a problem. But in this case, I want to attach the board on the cat's neck, but cat is really small. It's like 5 kilograms only, so we need to reduce the weight for the power source. Like, so we cannot use like maybe big power bank or something, some huge battery or even some computer on it. Yeah, because we need to make it portable. So in this case, after some trial, I use some lightweight. I consider some options like some lightweight power bank, which is a little expensive. So I did not buy that. And the second one is like a coin battery. This, well, you can link the two of the coin battery into the 6 volts setup, and you can power the our board. Yeah. And the second option is that a second problem is like how is I have a lot of difficulties set up the hardware because I'm not very familiar with those chips and those wires. Yeah. And I have asked a lot of questions and maybe have some discussion with Naveen and Yoovraj on Slack. Yeah, and I asked a lot of questions. So yeah, thanks for their help. So I may get something to them on this part. And also I checking a lot of video on how to connect those wire and how to set up those things. Yeah, and I found YouTube extremely useful because yeah, for somebody who did not know this kind of thing so well, I think you can just watch them and watch them how to install this kind of things. So if only on the article, I might get a little confused somehow. And onto the third problem, like this is actually a really huge problem because the cat does not like the board at all. Like first time when I trying to trying to install it on his neck, he just get really nervous. And the second time he got scared because I think he saw something in his neck in the mirror, and he got really like a jump scares. So yeah, he now really hate the board. So I need to find another like training method to how to train the cat to get familiar with something. So yeah, actually this one I also read a lot of article on how to train the cat, like using the clicker. And yeah, this is still in progress because maybe the cat need to get familiar with it and get used to training. So maybe it will take like a month or 2 months or so, depending on the cat. So yeah, this one is actually the trickiest problem. Yeah, because I just connect it and he will try to bite it off. Yeah. And so yeah, because I just want to test this kind of setup, like proof of concept, not very detailed, not very just a roughly testing. So this is on the left side, this is my board, and it is with a pre-solder header on it, and I connect it with my power bank. This power bank is really heavy, so it's carried by human, and just trying some setup with them. Actually, the cat got really pissed off after this first tryout, so I only done this once. Yeah, and this simple proof of concept is like I'm using power bank via USB source, so there's no problem of like overflowing or something. Yeah, and it's held by me on my hand. And I also attach the board inside his collar, like just use something to tie the board onto his collar very loosely, so that maybe may causing some problem, like the board may fall off in some cases. And the third one is, while the board is recording, I'm playing games with him, so he get like rush, or he's walking, or maybe jumping on the cat tower. Yeah, a lot of movement on that. And the data is transmitting by Bluetooth, which actually I'm using another speakers you look with setup. So I just downloaded a CSV file from via the Bluetooth. Yeah. And the last one is that I use a video at the same time to capture his movement. So like whether he's jumping or whether he is rush, and according to the time span, I can specify what movement he got and what movement has he made. Yeah, and this is the like raw sample of this kind of movement. So you can see that there's a lot of spike, and some spike, maybe he's rushing. And I think the last one, the huge spike, he is jumping up to cat tower for about 1.5 meters. So it's causing a really huge peak. And yeah, that actually also caused the board to a little, I think it's detached from his collar. Yeah, and after that, he really get pissed off because he did not know I attached this one into his neck. Yeah, so yeah, this kind of I think this is the progress until now. And after that, maybe I will try to, well, after he get familiar with the pro, I will try to record more data collection. Yeah, and I go into the second part because the second part is on the sounds. I just detect whether the sound is produced by a cat. So it's basically like a binary classifier. Yeah, and I'm using, in this setup, I did not collect the data by myself. I'm using a public data set. Yeah, and there's a lot of public data set, I think more than these two. But yeah, I'm using the audio set and ESC15 because they contains a lot of cat sound and other noises made by humans or made by the environmental sound. Yeah, and environmental source. And I'm using also using some sound processing library like Librosa or some file torch audio. Yeah, because I'm using some neural network to pre-processing the data. And I think there's maybe a CalD library is really fast, but is implemented in C++. Yeah, and I'm using this kind of stuff to do some pre-processing. And yeah, basically I just uploaded the pre-processing data to the Edge impulse for like making the feature generation, feature selection, training until to the deployment. Yeah, they really have a great end-to-end process. Yeah, that's really impressive. Yeah. And in the first trial, I just used the raw data, did not processing anything. So I just divide the data set to randomly choose noise and the other like cat sound. Like like maybe he's meowing or he's very angry, that kind of sound. And each audio file is like 10 seconds. Yeah, I just upload it to the Edge Impulse and just train the data for like a baseline. Yeah, and this model structure I used with is the same with Naveen's snore detection, because I found some of the network maybe too huge to handle on our board, and I did not have a lot of time to try this. So yeah, basically, thanks for Naveen. I just used your model structure, and also I clicked the video audio into like 1 second Windows land, and the feature is the spectrogram. And I think there's others feature generation method like MAFF, yeah, but I'm using spectrogram in this case. And at first, the test accuracy looks great, above 90% on the Edge Impulse website, but in reality, I barely cannot detect any cat sound, and yeah, I think the mod classifier just fails. So I do a little dive into the data set, and I found that some of the audio also, although it's categorized in like have the cat sound, but actually the cat sound is very brief, like maybe less than 2 seconds or 1.5 seconds. Yeah, so basically like the previous part, the front part of the audio, the 4 seconds or 5 seconds, maybe someone is talking to like, the cat is so cute and something like that, and the cat just meow like 1 minute, like 1 second, and other parts, wow, you are so cute, something like that. So the audio data is a little bit messy, and we cannot get just get the peak out of it, because sometimes the highest peak is made by human. So this is a problem, and I do a little search, and I found out that in July there's a really good model in transformer. It's called audio spectrogram transformer, and it has the highest score in the audio set classification. So basically, I just download their pre-trained model and use this model to like pre-processing my data to select the better data from my audio file. Yeah, and this model is really huge. So yeah, it takes maybe 1 hour to make inference on all of my data. Yeah, and yeah, the second trial, I just split the audio data is in 10 seconds, and I split it into several seconds, and I use this for data assessment. And also I define the like the good data is like the cat categories in top 25, because I also want to include some of the bad data in my setup. Yeah, some very small cat sounds or something. Yeah, and I sample from the top 25 data, and also the other part is the same with the previous trial. Yeah, and accuracy actually did not vary a lot. Yeah, but it has some good quality. And yeah, I will quickly jump to the YouTube for you guys to see that. Yeah, this one. Yeah. And this one in the screen part, the accuracy is varying, and when the cat is producing a sound, the classifier actually has a 94% accuracy. Yeah, and I cannot make my cat really meow at the time, because yeah, he's a little unreluctant to join my projects. Yeah. And that's all of my progress until now. And I think that this project I will actually continue to do this. And in the sound part, in the movement part, maybe I will collect more data, and also maybe use I will make my colors to fit the board into the color. And I also considering utilize other part of the IMU data, not just the acceleration. Yeah. And on the sound part, maybe I will examine I will also examine the sensitivity of the board, because I found that the board may be very sensitive to the distance. So the distance get longer, the classifier's accuracy may decrease. But did not have very rigorous experiment on it, so I'm not quite sure if this is the case. And also, I'm considering distillation like larger model, just make the small parts, maybe a small model overfitting on the larger model. Yeah, and also I'm trying to design it from scratch using the TF Lite, because I think Info has some limitation in in the deployment, or maybe I did not understand it very well. Yeah, but I also want to use TFLite from scratch. Yeah. And then the last part is that I want to combine these two things, or maybe I have another camera and some chip, so I can train maybe just monitor the cat, all of his movement and what is he doing right now. So this is my final plan, and it may be a long-term plan. Yeah. So yeah, my projects until now, and thanks Yoovraj and Naveen for helping me have this kind of this project, and also my girlfriend, because I cannot control my car really well, and she's really good at it. Yeah. So thank you, and this is my presentation.
Okay, with that, let me then move to the next presentation. Next presentation will be from Ludwig Stum on the project push-up activity. Unfortunately, he couldn't join the today's meeting, but he has sent a pre-recording to us. So I will play the pre-recording in this session.
Hello everyone, my name is Ludwig, and in the following I'm going to present you the project that I've been working on.
Is audio fine with everyone? Okay.
Which is the automatic classification of workout exercises. And here I'd actually like to start with my motivation for doing this. So before I was always using that one Android app called Adidas Workouts. And the thing that always bothered me was that whenever I finished with an exercise, I actually needed to reach my phone and then to press some kind of button to tell it that the exercise is finished and that I want to go on with the next one. And so for me, this process kind of always felt very unnatural. So I asked myself, hey, why not build something that can keep track of your exercises that you're doing automatically without you pressing any buttons? And then on another more top level, I saw this project as an opportunity to familiarize myself with the Edge AI use cases, the common workflows, and also to get some real hands-on experience. And then lastly, but also very important for me, was that I'd like to motivate you and other Machine Learning Tokyo members to get started with simply trying out stuff in real projects, because I think we at first are all a little bit afraid of getting started, but these things are actually not that difficult. Let's continue with the project scope. So to get an overview about the project, I thought of the task as a classification of 3 exercise types, which are jumping jacks, push-ups, and squats. Of course, one can then think of adding data for other exercises, but I chose these 3 to get started. And then the inference is running on an edge device. And during inference time, what I would like to do is to have some kind of dashboard that shows you for how long you were doing each exercise. The whole project took me 4 weeks. Besides my regular job, that's why I did not have that much time. Here you can see an overview about the hardware that was required for me to build that project. And on the very left, obviously you need some kind of edge device, which for my case was the Arduino Nano 33 BLE Sense. I chose that board because its dimensions are very, very small, so it can be used for these mobile applications pretty well. And then it also has a 9-axis inertial sensor, which means 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer. Then what is important for these Edge AI solutions is that it supports the TensorFlow Lite library. And this BLE board also supports Bluetooth Low Energy, which is called BLE. That is useful for sending data over BLE, which is basically wireless and does not require a connection via a USB cable. Obviously, one alternative would be to use the Arduino Nano 33 BLE board, so without the Sense. But the Sense board has a lot of more variety of different sensors that can be used for future projects. Below each box you can also see a rough estimate of the price for each component. Then the next one is a case, which is the one displayed here, which is great because it just improves the handling of your board and also its protection. Then one obviously needs a cable to connect it to your computer for flashing programs on the device or for power connection as well. And then for the power connection to be mobile, I chose to use a power bank. One alternative could be to use an external battery, but I did not have any, so I decided to use the power bank here. Let's move on with the software requirements. First of all, you obviously need the Arduino IDE to write the code, to upload it to the board, and also, which is very important, this project to make use of third-party libraries. Then I decided to use the Edge Impulse platform that was also introduced in one of the earlier videos of these Edge AI series. And that platform is really great to get started because it offers an end-to-end solution for Edge AI devices. So basically from data collection over to preprocessing, training, testing, and then model deployment back on your board. And it's free for individuals. So that's really a great tool to get started quickly. Then for my specific project, I also needed a web browser that is able to use the Bluetooth Low Energy interface, which is, for example, the Chrome web browser. And I use that for recording the training data and for the visualization of the data during inference. And lastly, I also needed Python because the data that I was recording did not have a constant sampling rate, so I needed to resample, and this was done by using a Python script that I was quickly writing down myself. Now, after that I've talked you through the hardware and software requirements, I'd actually would like to go a little bit further into the process of the Edge AI pipeline, so which steps were required and what I was doing during these steps. And here I would like to start with the data collection and the storage of the training data. So I decided to use the data of the accelerometer in X, Y, and Z direction. And basically how that looked like is that I've placed my board connected to a power bank in my pocket of my sports trousers, and then I just started the recording while also performing one specific exercise, and then I stopped the recording. I've started with another exercise, and so on. So that's basically how I collected the data. The data was then sent during the recording via Bluetooth Low Energy from the Arduino bit itself to a website that was running locally on my computer. I was doing that because then I also only needed a connection from the board to a power bank, but not to the computer, which might have been very inconvenient while doing jumping jacks, for example. And after I've recorded the data, it was then converted and downloaded as a CSV file on my local machine. In the end, I got 30 seconds per exercise total that consisted of 4 different board orientations each, which was important to make it a little bit robust against the orientation of the board, which of course has an influence on the data in X, Y, and Z direction. But more to that later. Here you can also see a link to the repository of the Bluetooth Low Energy recorder. Feel free to use that. It's pretty helpful to record training data. Yes, and then after I've collected all the data, I uploaded it to the Edge Impulse platform. Here you can see a few pictures of that step. On the very left, you have the Arduino board inside the case, which is connected to a power bank. And while doing the exercise, I had the power bank in one pocket and the Arduino in the other one, which of course was not optimal, but it was a good solution to just get started. Then in the middle you can see my recorder tool. Basically what one needed to do was to specify the message format. So it was like basically a string where we had a delimiter symbol in between parts of information, and then the tool recorded that data, split it into its individual parts, and combined that into a CSV file, which you can see on the right. In that CSV file, you can see we have a timestamp in milliseconds, and then we have the acceleration data in X, Y, and Z direction of the board. One can also see that the sample rate was almost always 20 seconds. But this, as the recording goes, this was not very consistent. Next, I'd like to talk about the preprocessing and the training pipeline. So for preprocessing, as I mentioned earlier, I had the issue that my data was not sampled at a constant sampling rate. So I wrote a very quick Python script that uses standard linear interpolation to fix that. So that in the end I have a constant rate of 15 Hertz, which means that following the Shannon-Nyquist sampling theorem, that I'm able to capture all the information of a signal with at most 25 Hertz, which obviously was way above my expectations for a workout classification. And then for the training pipeline, I was making use of the capabilities of the Edge Impulse platform. And what they do is that they provide some form of standard spectral analysis. So they first apply a low pass filter to get rid of high frequent noise. And then they are splitting, or they are observing your time series in windows with a fixed length. And for each window that they are sliding over your time series, they do a fast Fourier transform to get it from the time domain into the frequency domain, and then from that frequency signal, they are generating 33 features for each of the windows. In my use case, this then led to 84 training samples in total. And for the network, I was using a standard fully connected forward neural network with these 33 inputs, as they were the features of each window. I was using 2 hidden layers and finally 3 outputs for the 3 classes of exercises that I wanted to predict. What you can see here is an overview about the whole training pipeline, basically. That screenshot is directly coming from the Edge Impulse platform. On the left, you can see the time series data as an input with a windows size of 3000 milliseconds. Here it is just important to make it large enough that it captures a little bit more than one period of your exercise. So for example, if you're doing push-ups, then you need to make sure that these are faster than, well, let's say 3000 milliseconds each. You also specify the frequency, for example, and by how much you want to shift the windows when collecting the data, when putting the training data into the system. Next, we have the spectral analysis, and what goes in there are the 3 acceleration values, as you can see, and the output of that spectral analysis are the 33 features. The next step is the classification using a Keras neural network. And finally, you have the outputs, which are 3 nodes or three probabilities for jumping jacks, push-ups, and squats. On the next slide, you can see on the very left an overview about these spectral features. You can see again the window length of 3 seconds, the window increase of 300 milliseconds, that we finally have 84 windows inside our training set. And then on the right, you can see a visualization of one of these features, which here is the root mean square for push-ups, squats, and jumping jacks, where each point is one training sample, so one window of a length of 3 seconds. On the right, you can see the very simple architecture of the neural network. There was really nothing special. I just took what Edge Impulse was recommending me. What is obviously fixed is the number of, or the size of the input layer, because that needs to match with the numbers of features you have for each sample, which, as I mentioned, was 33. And then the size of the output layer matches the number of labels you have, or the number of classes, so to say, which in my case is also, or is 3. 1 for push-ups, then we have jumping jacks, and finally squats. Cool. So then after I finished the training and did some testing with a separate test set, this is important, separate. The next step then is model deployment and inference. For model deployment, there are 2 options that the Edge Impulse platform offers you. First is to export a library, a Arduino library that you can use. that was the one I chose. But you could also export everything as a firmware. But since I was also making use later of the Bluetooth Low Energy feature of my board, I needed to modify the code first. So this is why I chose to export everything as a Arduino library. I also used the optimized version to increase the on-device performance, which for these real-time sports activity tasks is important, and also because I did not notice any decrease in accuracy. Okay, so then everything is deployed on my board, but actually before that I also need to extend the code a little bit. So Edge Impulse provides you a demo on how to use your classifier on the Arduino board that is provided. But additionally, what I wanted to do was to send that prediction target over with Bluetooth Low Energy to my visualization that is running as a web app on my computer. So therefore I needed to customize the code a little bit in order to send the data via Bluetooth Low Energy. So then during Inference, so right, I have my board in my pocket, it's connected to a power bank, I am doing my push-ups, and during or after each Inference run, after each prediction, the board is then sending the target that it thinks to my web app running on my computer via Bluetooth Low Energy. And then on the web app, I can see the accumulated exercise durations. Here is a quick demo of the web app. At the very top in raw data, you can see the current exercise being detected. And then at the bottom, you can see the accumulated duration for each exercise. So basically you see at the top, now it's push-ups, and push-ups is counting up. Let's wait a little bit. Here I'm switching the exercise, that's why it's saying uncertain. Now I'm doing
It's
jumping
6
jacks,
o'clock.
and look down below, jumping jacks is increasing. So that's basically my web app that is running on my computer, and the Arduino after each prediction is sending the data over to my computer using Bluetooth Low Energy. We are almost done with my presentation. Here is a slide where I quickly want to summarize a few challenges that I had to cope with and a few solutions that I came up with. So first of all, naturally, if you want to record training data, you need a connection to your computer. At least if you are sending the data over the serial connection. But this is totally uncomfortable for sports exercises, because imagine you doing jumping jacks while having a connection via cable to your computer, and then the cable is flickering around all the time and everything is really messy. So this is why I came up with that Bluetooth Low Energy solution that is wireless, and this was also the reason for me to develop that web app to record that data into a CSV format. And one then only requires a connection to a power bank, which is way more comfortable than having a cable to your computer all the time. The next issue that I had to face was that the features for the classification, so the acceleration values X, Y, Z, and then later from there on the spectral features after the spectral analysis, that they rely on the orientation of the board. This obviously makes a lot of sense, since the total acceleration is split into a X, Y, and Z component. And that obviously depends on the orientation of the board. So in order to cope with that, I simply tried to collect more data in different board orientations. One alternative I thought of could have been to use PCA, so the principal component analysis, on the raw data to make it align on the axis of the highest variance, which is the highest acceleration change or spectrum, so to say. But I did not test that since the Edge Impulse platform does not allow that sort of preprocessing, and I wanted to have a working solution rather quickly. And then the last point here, the last issue is that the board is slightly moving while performing the exercise. Well, obviously because it's loose inside your pocket. This is still an issue. That there was no attachment to my sports pants, and the power bank has a high weight, so everything is shaking, etc. And here the idea might be to use a lightweight battery instead, or to improve the packaging, have an attachment to your pants, something along that direction. Finally, it's my time for a call to action. As a little bit of encouragement, actually getting started with these Edge AI projects as the one that I was now presenting is rather easy when you use the Edge Impulse platform. You also do not need any prior knowledge regarding electrical engineering because like for example for this project, all the sensors are directly on the board. You do not need any additional wiring around it. You do not need any additional sensors, etc. So getting started is really easy, and if I could do it, then you can do it too. So that was my presentation about my workout classification project. Thank you for listening. I hope that you've learned something. If you have any questions left, really anything, feel free to reach out via the Machine Learning Tokyo Slack or contact me on Twitter. Also, here you can see the two links for first the Bluetooth Low Energy Recorder web app, and second for the rest of the project. So feel free to check them out, and thank you.
Thank you, Ludwig. I think this was really nice project too. So okay, so I think this is the last session of this series, and I would really like to thank Naveen, Alisher, and the MLT team, Susanna, and the other for helping us to create such kind of giving the opportunity to create such kind of series, and also definitely the entire Edge AI Lab members, because I think without their support, it would be difficult to have such kind of projects. And the problem with always these kind of projects is like when it comes to hardware, initially a lot of people think that you don't have hardware, so we cannot do anything. But you can see like a lot of I think the hardware, if you select some hardware which it's not that costly, and with some few bucks, I think we can get that hardware and start working on it without any electrical engineering experience. So I think once we have those things started, I think we can easily develop our own projects. And that's why like I would like to really thank the other members, community members in the channel, which help to answer some of queries of some of the users. So with that, I think even if this is last session, I still don't want to mention this as last session, because these projects are still like Ludwig and Lynn has created these projects as prototypes. And if you are interested in working more on those prototypes and convert them into projects or products, we will want to encourage everyone to like throw your ideas, throw your suggestions and feedback in the Edge AI Lab channel, so that we can like convert these prototypes into actual production. And it would be cool to have such kind of like devices around, if you could make things by yourself, and looking into how these projects get converted into product. So utilize the Edge AI community channel on MLT Slack to work together on this kind of like cool hardware and AI projects. uh, I think we have experts like Naveen who are there to guide us around like the different type of hardwares, because people were not just Arduino Nano, but also like other microcontrollers, if you want to challenge with some new microcontrollers. So yeah, I think that's it from my side. Naveen, do you want to like give any comments for the community?
Yeah, thank you, Yoovraj. So I'm glad to see two projects come up from the community, and I think they made a great progress. And I want other members from the community to come up with some idea and submit their projects, or let's just discuss over Slack about future implementation, or just start with some ideas. So that would be grateful, helpful. So thank you, everyone.
Then I think that's it for us. See you around on the channel, AGI channel.